Hello, my name is Sahil, and this presentation is about first assessment programming assessment for the subject of artificial intelligence. So, in this assessment, we'll be solving the 8 puzzle problem. So, to set some context, 8 puzzle problem is in metric 3 by 3 matrix of integers from 1 to 8 and an empty position. So, our goal is to somehow rearrange the matrix in such a way that all the elements are ascending in clockwise order with empty state in the middle. So this is my implementation for the solution. So we'll be implementing BFS and DFS. So BFS is and trees, both of them are tree traversal algorithm, but for BFS the traversal is done on the breadth order, that is we move from one breadth to another, so A, B, C, D, E, F. And for DFS the traversal is done in the depth order, so we go as deep as possible. So that's A, D, F, then next C, E, then next B. So this is the algorithm that we will be trying to implement. So I created some helper function because I usually follow the do not repeat yourself approach. Display matrix to display the matrix, find the position, check whether the current state is a goal state. Because it's a 3 by 3 matrix, and for all 3 by 3 matrix the solution will be same. I just used a constant just to simplify the things, but if we would be using matrix of different width and height, this function would have just have an generic solution. But for our case this works fine, and I like to keep it simple. Check that the move that we are trying to move for rearranging the matrix, is it valid or not, that is it doesn't breach the matrix boundaries. uh, Create the copy of matrix, because in Python lists are passed by reference, so we manually need to convert that to string so that we can store that in the set, because set needs hashable data structures and lists by default are not hashable, so we convert them to string. So first we are trying to solve the DFS. So the main difference between DFS and BFS from coding perspective is the data structure that we use to store the path. So in DFS we use stack because we want to process last element first, and BFS we use queue. Why we use stack? If you see the example here, so if we have a stack here and we start with A, we want to process the last element first, so we add B, C, D. Now we want to go as deep as possible, we need to process the last element first, so we pop D, add its children here F, and if let's say there were more children here X and Y, now we want to go even deep, so we pop F, add X and Y. If we want to go even deep, we pop Y. If there were children, we add those, and this process continue, and we will notice that we go as deep as possible. So that's why we're using the stack. So the logic here is I've created a flowchart and pseudocode for easy understanding. So we find the empty position, initialize the stack, and explode state with problem statement. We check whether the stack is empty. If the stack is not empty, we pop the last element like we discussed. Check whether it's the solution. If it is not, we try to rearrange the matrix. We can rearrange the matrix by moving them and swapping the elements up, down, left, bottom. We try to do that with all four directions. If that is a valid move, that is not breaching the boundaries, we move that, create a new matrix by swapping the elements, create the signature. We check whether the signature doesn't is not already seen, because that can cause cycles in the logic which we want to avoid. So if it is already seen, we just avoid it. If it is not, we add that to explode and search stack, and we do this for all four directions. And once all four directions are completed, we then go to the main loop here, and we again do the same process again. We pop the last element, check if it's the solution, and this process continued like we just did for our example above. And this is the output of these DFS. I started with the same problem that's in the problem assignment, and we can see that it goes as deep as possible. So if we open the output, we can see that it goes as deep as possible, and it's just moving one element at a time. It, like here, it went right, up, left, left, and so on. It goes as deep as possible, and which can see that the solution was found at pretty deep state of 3407, and the number of states which were explored before finding the solution was 6269. So we can see it goes quite deep now. And for the BFS, the solution is same. The only difference is that we use Q now because we want to visit first element first. So we go A, we pop Q, add B, C, D, add B, C, D, pop B, we doesn't have any children, pop C, it has E, then pop D, it has F, and pop E and pop F. So we can see we go A, B, C, D, E, F. So that's the exactly breadth we are trying to explore. So that's why we use Q in case of BFS. And the logic is same. We initialize the Q, we pop the element, pop left. That means we are trying to find the FIFO approach here. Is it goal state? If it is not, we go in all directions, in all four directions. If it is invalid move, we move that move, we do that move, create the signature. If the signature is not in the explode state, we add that to the queue, and this process continues until we found the goal state. So that's the BFS algorithm, and when I run this algorithm, we can say that it is going breadthwise. So 0 1 1 1 2 2 2 2 and so on. It is exploring all these states depthwise. And for the solution, we found that the solution depth was just found at the depth 5 instead of 3000 something at that site, and we just explored 62 states before finding the solution, which is 100 almost 100 times approximately 100 times less than the DFS. So after that we can conclude that obviously BFS gave us the most optimal solution, and I hope I was able to explain the logic as clearly as possible. Thank you for your time and have a nice day.